All right, cool. So first of all, welcome everyone. This is the second class we're doing today, so I think we might have worked out a few kinks. If anybody has any questions, feel free to raise your hand at any time. The restroom is in the back. And I think that's pretty much it. OK, so just to get you started, let me tell you a little bit about Assistant Editors Bootcamp. So the idea behind Assistant Editors Bootcamp, I started it about, or we both started it, Connor and I, about a year and a half ago. And basically, I saw that there were a lot of people coming to me who were interested in getting into the industry, and they wanted to sort of, get help to the point where they could potentially be able to get a job. And I helped several people, and I was able to help them get jobs. But I found that I was spending like 6 to 8 hours with each person trying to help them, to the point where I could actually recommend them for something. And it was great, and I really enjoyed doing it, but it was also unsustainable for more than just a few people. So I had the idea of, instead of doing that, maybe doing the same kind of instruction, but in a class setting. So Connor and I put together a class about beginning of 2017. And the class was specifically geared toward reality assistant editing. But the class went well, and since then we've sort of realized that the format actually works well for a lot of other things. So we've started doing some free classes. Our class today, as you know, is on I/O and drive speed. And we think that it's sort of a good opportunity for everybody to learn some of the stuff that you don't really have time or the resources to learn on the job. So just to give you a little background on me, I worked as an assistant editor in reality TV for about 5 years. And during that time, I realized that I really liked my job, and I wanted to move up, but I wasn't that interested in the editing part of it. I was much more interested in the technical side of it. So I moved into engineering. I worked as an Avid engineer for about a year and a half, and I enjoyed it. But from then, I moved on to my current job, which is actually, I work as an I/O supervisor at Level 3 Post in Burbank. And basically what I do is my department is in charge of anything that goes into or leaves the building. So all of the media that is coming from other facilities, all of the files that need to be generated for, we do online for scripted television, so all of the files that need to be generated for the network or for executives from the final colored master, that's our job. So as you can imagine, I'm pretty familiar with I/O and drive speed. The specific reason that I wanted to do this class, though, is because I've found that there's a lot of need to understand this information, but it's really hard to get a comprehensive overview of what all of it means. I mean, there's a lot of stats out there, and there's a lot of, this can do this and that can do that. But there's not really a lot of context for what the numbers mean and what numbers you care about and what numbers you don't, and how this applies to video. And so that's sort of the stuff that we're going to be going over in this class. So we're going to be covering, first of all, cables and transfer speeds. Then we'll talk about drive speed itself. We'll talk about RAIDs, shared storage, drive formats, and drive mounting. So what I'd like to start with is, before we get into cables or connectors or drives, let's talk a little bit about how speed itself is measured. Like, when we're talking about a hard drive, how do we figure out how fast that hard drive is? Well, speed in general is either measured in megabits per second or megabytes per second. It can also be measured in gigabits or gigabytes. The lowercase b stands for bits, so megabits is uppercase M, lowercase b. Megabytes is uppercase M, uppercase b. And the uppercase b stands for bytes. So why do we have these two different ways of quoting numbers for transferring? I'm not quite sure. I can't tell you offhand. But I can tell you the relationship between the two of them, which is that when we're talking about on paper, there are 8 bits to each byte. So if you're doing the math, actually, I won't get into that because I won't really be using that number very often. But just know that scientifically there are 8 bits to each byte. So transfer speed is usually measured in megabits. So for example, when you talk to your internet provider, let's say Comcast, if you're talking to them about your internet speed, they're going to tell you you have, let's say, 20 down and 10 up. That means that you have 20 megabits per second download speeds and 10 megabits per second upload speeds. So usually file transfer speeds are quoted in bits per second, megabits, gigabits, things like that. File size is usually measured in bytes. So when you buy a hard drive, it's usually 150 gigabytes or 2 terabytes or something like that. You don't usually hear bits when you're talking about file size. So that's usually the distinction between the two. It's not a hard and fast distinction. Sometimes speed is measured in bytes. But what exactly is the relationship between the two? I mentioned that there's 8 bits to each byte, but when we're talking about day-to-day numbers, it's actually a lot easier and sometimes even a little more accurate to think about it as speed in megabytes per second is effectively 1/10 of megabits per second. So if I have something that is 1,000 megabits per second, it's effectively 100 megabytes per second. Does that make sense to everybody? Okay. So when we're talking about megabits and megabytes or gigabits and gigabytes, you'll notice that before bit and byte, there's actually a prefix. And that prefix is a metric prefix. And you've seen it in other places like meters and I keep thinking gallons, but that's not metric. Other metric measurements. So if we look at a chart, we have at the very bottom 1,000, which is kilo, 1,000,000, which is mega, 1,000,000,000, which is giga, trillion, which is tera, and then quadrillion, which is peta. So these can be applied to bits or bytes. You can have a kilobit or a kilobyte. Same thing with all of these. So let's talk a little bit about connection interfaces. So connection interfaces have been around as long as things have needed to be connected. But as far as connections that we still see today, I'm going to start with FireWire. So there are 2 versions of FireWire. The first version was FireWire 400. FireWire 400 has a connector that either looks like this or like this. It was used in the early days of cameras to connect to a computer. And FireWire 400 has a transfer rate of 400 megabits per second, which is, you'll notice I have down here effectively. That's because on paper, it's actually 1/8 the speed, but in real life use, it's about 1/10 the speed. So that's effectively 40 megabytes a second. So if you have a FireWire 400 drive, that means that you're not going to get any more than 40 megabytes a second from that drive. Next, we have USB 2. So USB 2 has a transfer rate of 480 megabits per second. So that's pretty similar to FireWire 400. That's about 48 megabytes a second. And you'll notice that there are a bunch of different connectors for USB 2. And I'll go over that in just a second. So after that, we have FireWire 800. FireWire 800 has a transfer rate of 800 megabits per second, which is approximately 80 megabytes a second. So just to reiterate, that means that if you have a hard drive that has FireWire, the fastest speed that you're going to get out of it is about 80 megabytes a second. Then we have eSATA. eSATA was much more common on PCs. It was never built into any Macs. Oh, I didn't give you the spiel about Macs. So I'm specifically covering, I'm covering a lot of Macs in this class, connection interfaces, compatibility, because I know that Macs are very common in LA and in the industry. If you are more familiar with PCs, I'll be covering those as well. But just so you know, most of the stuff that I specifically refer to is related to Apple devices. So with eSATA, it's based on the SATA protocol, which means that it can have a transfer rate of between 1.5 and 6 gigabits per second, which is effectively 150 to 600 megabytes a second. Next, we have USB 3. So USB 3, you'll notice it looks slightly different because the connectors are usually blue. So if you have a USB 3 cable, usually the little, I think it's called the tongue, that's in the USB connector is blue, and that indicates to you that this is a USB 3 cable. So if it's a white connector, then it's usually USB 2. If it's blue, it's usually USB 3. But you'll notice that these connectors on USB 3 actually look pretty similar to the connectors in USB 2. And the reason for that is because they're actually designed to be backward compatible. So if you look at the connector for micro B, for example, you'll notice that this part of the micro B connector looks exactly the same or extremely similar to this part of the USB 2 micro B connector. And the reason for that is that they are exactly the same. The only part that's different is this little piece over here. So technically, if you have a USB 3 drive and a USB 2 cable, you could actually plug the cable with that connector into this port, and it would give you USB 2 speeds. Sorry, it would work, it would just give you USB 2 speeds. And the same is actually true with the full-size connector. So if you have a full-size USB 3 connector, you'll notice that this bottom part's the same, it's only the top that's different. If you have a cable that looks like this, which people usually refer to as a printer cable, because it's usually printers that have full-size USB 2, you could actually use this cable and plug it into this port. Does that make sense to everyone? Nobody's lost or anything? Okay. Okay, cool. So next we have Thunderbolt. So Thunderbolt the original version was introduced in 2011, and then Thunderbolt 2 was introduced in 2013. But before Thunderbolt, we actually had something that gave us the connector for Thunderbolt. So in approximately 2008, Apple switched to a connector for video called Mini DisplayPort. DisplayPort's actually a protocol. A protocol is basically a language. But DisplayPort's a protocol, but they introduced a connector called a Mini DisplayPort connector. And it looks kind of like this. You've probably seen it before on a computer. So with Mini DisplayPort, they introduced it on the 2008-ish MacBook Pros. And when they came out with Thunderbolt, they decided to reuse the same connector, but use a completely different protocol. So you'll notice that, for example, on an older Mac Pro, if you look at the back on the video card, sometimes it'll have a port like this, and it'll have this icon, but it's not actually Thunderbolt. Thunderbolt will always have this icon. So even though Thunderbolt uses a mini DisplayPort port, it carries a different protocol from a mini DisplayPort cable. Does that make any sense? OK, cool. So when we're talking about Thunderbolt, there are two transfer rates depending on which version. Thunderbolt 1 is 10 gigabits per second, which is about 1 gigabyte per second. Thunderbolt 2 is 20 gigabits per second, which is about 2 gigabytes per second. So it's pretty fast. Next, we have one that you may not have heard of. It's called USB 3.1 Gen 2. So USB 3.1 Gen 2 is actually a faster version of USB 3, basically. But the USB Implementers Forum, or the IF, when they decided to create this new faster version of USB, they also, for some reason, decided to rename USB 3.0. So if you look at new products that ship with USB 3.0, you'll notice that they're actually labeled as USB 3.1 Gen 1. But if you see that, it's exactly the same as USB 3.0. It's just that they've retroactively renamed the protocol. So USB 3.1 Gen 1 or USB 3.0 will have these connectors, and it will give you 5 gigabits per second. Does that make sense to everybody? Yeah.
So for the new generation, it doesn't have the type B.
Right. So the point that was made is that that 3.1 Gen 2 only has a type A and a type C. So what happened to type B? So with USB type C, the idea, you'll notice that type A and type B are actually the two ends of a cable. So the type A end would always plug into your computer, and the type B end would always plug into a device. So for example, this would plug into your laptop, this would plug into the printer, right? So this is type A, type B. These are called micro B and mini B because they're the same components as this, but in a smaller package. So this will plug into your phone, this will plug into your camera, and it carries the same signals as this type B. When they looked at USB-C, they realized that they really no longer needed to differentiate between the end that goes into the computer and the end that goes into the device. So when they created USB Type-C, instead of having an A and a B end, we now have a C end that works, that can plug both into the computer and into the device. So when we're talking about USB 3.1 Gen 2, they didn't see any reason to have a B connector because they're trying to move away from it. So in general, with USB 3.1 Gen 2, it will either have Type C at both ends or Type C and Type A. Does that make sense?
Why would they switch to Type A?
Backward compatibility. Because they don't want to get rid of something altogether because people will get annoyed. Although a lot of what I'm talking about is pretty annoying. OK, so I mentioned before that Apple introduced Thunderbolt. Well, Thunderbolt has been kind of a mixed bag for usage. A lot of people used it, but mostly in the entertainment industry or anywhere where they needed high-speed connections. And over the years, USB has only gotten faster. So it became kind of frustrating because you had these two connectors that theoretically did pretty much the same thing, but they weren't backward compatible. So when I mentioned that Apple introduced Thunderbolt, but they developed it with Intel. So when Intel looked at the next version of Thunderbolt, they thought, well, maybe instead of doing another version of Thunderbolt with this connector, we could do a version of Thunderbolt that uses the same connector as USB, because then we could make it so that they're backward compatible, and it'd be a lot easier to sell Thunderbolt because it would fit in with everything else you already have. So Thunderbolt 3 uses a Type-C connector with a transfer rate of 40 gigabits per second or 4 gigabytes per second. So these are all of the device connections, but let's take a look at network connections. First one is Ethernet. So Ethernet's been around for a while. In general, with Ethernet, you're getting gigabit Ethernet, and gigabit Ethernet means 1,000 megabits, or 1 gigabit, which means that it's 100 megabytes. So with a single Ethernet cable, 90% of the time, you're looking at 100 megabytes per second. Sorry, one second. But you'll notice here that it says 10 gigabits per second. Well, with Ethernet, the cabling is copper, and it can actually go faster than a gigabit per second. It can do, I don't know if it can do faster than 10 gigs, but you can actually do 10 gigabit Ethernet over a copper connection. And if you've ever seen the iMac Pro, you wouldn't notice it, but the port on the back of the iMac Pro is actually 10 gigabit Ethernet. So you could connect two iMac Pros, theoretically, and get 10 gigabit speeds with the Ethernet cable. Or if you have 10 gigabit networking with a copper wire, because usually it's fiber, but if you have 10 gigabit networking, then you could plug a 10 gig connector into the back of your iMac Pro, and you'd have 1,000 megabytes a second, or a gigabyte a second, over a network. But usually, when we're talking about fast connections over a network, we're looking at fiber. And fiber can give you anywhere from 4 to 32 gigabits per second, which means 400 megabytes all the way up to 3.2 gigabytes a second. It's pretty fast. It's not quite as fast as Thunderbolt 3, but it's pretty fast. Does anybody have any questions before I move on? Okay. So I've been talking about, excuse me, I've been talking about all these ports, but ports are only half the story when we're talking about plugging something into the back of a computer. And the reason for that is that the port is not the only thing that controls the speed coming out of the computer. There's actually something else called a bus. So a port is the physical connector on the device. So for example, on the back of a Mac Pro, if it's lit up like this, you'll notice that there are 6 Thunderbolt ports, right? Everybody sees that? I mean, it might be kind of hard to see, but just trust me that there are 6 Thunderbolt ports here. So you'd think, well, each of these is Thunderbolt 2, and Thunderbolt 2 is 20 gigabits a second, so I have 6 times 20 gigabits a second, I think 120 gigabits a second. But you would be wrong. And the reason for that is that every port has to be on a bus. And a bus is the computer chip that controls the connection. So on the Mac Pro, for example, if we look at the Thunderbolt bus, you'll notice that each bus has 2 ports. So that means that each bus here is able to produce 20 gigabits per second. But that means that if you have 2 things plugged in, they're going to have to share that 20 gigabits per second. So a bus can only provide full bandwidth to a single port. So that, therefore, the speed of a port is determined by the number of other ports in use on the bus. Does that make sense to everyone? There was a question in the last class about whether you can have different connectors or different ports on the same bus. You can, as long as the protocols that the connectors transfer are backward compatible. So for example, if you look at the Mac Pro here, you'll notice that these two Thunderbolt ports are on bus 0, but the HDMI port is also on bus 0. The reason for that is that Thunderbolt actually carries a video signal, so this HDMI port can actually be fed by the bus that feeds these. But it also means that if you have, let's say, two 4K monitors and you plug one of them in here and one of them in here, because these are on the same bus, you're probably not going to get a signal on one of your monitors. Does that make sense to everyone?
How do you know what it's like in the computer that you're buying?
So the question is, how do you know what the bus and port configuration is on the computer? So unfortunately, a lot of computer ports are well documented because all you have to do is look at the port to see what kind of port it is, or you can look up in the documentation what kind of port it is. Unfortunately, the bus configuration is usually pretty poorly documented. The Mac Pro is a very common system among high-end configurations, so it was easy to find this documentation. When I tried to find the same documentation for an Apple laptop, a MacBook Pro, it was much harder, and I don't even know if I ended up finding it. So as a rule of thumb, especially on a laptop, if two ports are next to each other, usually they're on the same bus. If two ports are on two different sides of the laptop, they're probably on different buses. Just because it makes more sense to have two things that are right next to each other connecting to the same chip than if they're on two completely different sides of the machine. If you're looking at the back of a computer, it's hard to say.
So I have a MacBook Pro and
Can you hand her the...
I have a MacBook Pro. Yeah, so I do have a MacBook Pro that's like on both sides you have the USB, and I think they're 3.1, the first generation that came out. And so are they equal? I mean, if they're on
Are they on different buses, you mean?
Well, I mean, I'm assuming that they're on different buses, but isn't it like, because some people are saying you should be plugging it on the left side because the one on the right side is less powered or something?
What MacBook Pro do you have?
It's the 2012, mid-2012.
As far as I know, the power is the same on both sides.
Right.
I would guess that they're on this. I'm really not sure what the bus configuration is, so it's really hard to say.
So they should all be the same, so you can plug in like your drives, external drives to anyone, and it shouldn't matter.
On Macs in general, Apple doesn't usually sacrifice anything on their ports. On the 13-inch MacBook Pro that they released a couple of years ago, one side of it was actually slower than the other side, but that was really well documented. And not so much because Apple wanted it to be, but just because people were really annoyed about it.
Okay, but now these...
In general, especially if you have a Mac, all of the ports are, for the most part, going to be the same. If you have a PC, there should be some kind of logo that'll tell you what the port is capable of. Like if it's USB 2, it should be a USB 2 logo. If it's USB 3, it should be a USB 3 logo. Does that make sense?
Yeah.
Okay, so next let's talk a little bit about Thunderbolt. So Thunderbolt is unique when we're talking about ports because it's not limited to data transfer. So with USB, for example, all you can really accomplish with the USB protocol is copying a file or any kind of data transfer. But Thunderbolt is a little different. So Thunderbolt was developed by Apple and Intel, and it was first released in 2011. And Thunderbolt actually incorporates something called PCI Express, as well as DisplayPort over a single cable. So what's PCI Express? Well, PCI Express is something you've seen if you've ever looked at the inside of a desktop computer. So PCI Express is basically a direct connection to the computer's motherboard. So you'll notice here that there are a bunch of slots in the computer. These are all PCI Express slots, And these give you a very fast connection to the computer. There are different types of PCI Express slots, so you'll notice that some are longer than other ones, but in general, they're all very fast. And they're rated at there's like 16x versus 8x. The ones with higher numbers are faster. But basically, PCI Express is a direct connection to the motherboard. And any machine that has, let's say you have a PC, for example, that has an output on the back of it for a client monitor. That's going to be plugged in to a card, a PCI card, that's plugged into one of these ports. And that's because, as I mentioned before, it's a low-level connection, and it gives you a really fast speed. So PCI Express acts as an extension of the motherboard. It basically allows you to connect things to the computer that are capable of being as fast as the things that are already built into the computer. So because of that, Thunderbolt not only allows for high-speed data transfer, but it also allows for external components. So, for example, you've probably heard of a Thunderbolt dock. And the reason for that is that, unlike USB, which speaks its own language, the USB protocol, Thunderbolt, you can think of it as like Thunderbolt actually speaks the language that the computer thinks in. So PCI Express is the native language of the computer, and Thunderbolt speaks PCI Express. And so because of that, it's able to have all of these connections that you would otherwise need built into the computer. So for example, on this dock, you've got USB, you've got FireWire, you've got Ethernet, and you've got a display connection. And all of these are being transferred over a single Thunderbolt cable. But you can do more than that with Thunderbolt as well, because you can actually use it to expand the capabilities of the computer by using something called an expansion chassis. So for example, if you have a Mac Pro, a trash can Mac Pro or cylinder Mac Pro, and you want a playback device that is only sold as a PCI Express card, you could actually purchase an expansion chassis like this and install the card, connect this via Thunderbolt to your computer, and it'd be just as if that card were actually in the machine itself. And that's because Thunderbolt carries the same PCI Express connection that you would get if you were to put it into the computer. More recently, initially there was sort of a problem because with PCI Express, oftentimes people will add video cards to systems. And video cards are extremely demanding. They require really fast connections via PCI Express. And with the first two versions of Thunderbolt, that wasn't really doable because there wasn't enough data to actually provide the information that the video card needed to do its job. With Thunderbolt 3, though, Thunderbolt 3 is actually fast enough that you can actually connect an external video card to even like a laptop, and you can use it almost as if it was in the computer itself. And this is all through PCI Express. So, for example, Apple and Blackmagic introduced an external video card about a month and a half ago that you're supposed to use with your MacBook Pro, or I don't think it's compatible with PCs, but there are all kinds of PCs that have Thunderbolt 3 that you could plug a video card into as well. And in the newer versions of the Mac operating system, you can actually plug the video card in while the computer's already running and then unplug it when you're done, and it works perfectly. Or at least from what I've heard, it works perfectly. So by doing this, you can actually get a much faster performing graphics card than you have built into your system. So Thunderbolt is actually really powerful. But let's talk a little bit more about Thunderbolt 3. So how did we get Thunderbolt 3? So I mentioned before that Intel decided to change the connector. So the original Thunderbolt incorporated PCI Express and DisplayPort over a single cable with a, as I said before, a mini DisplayPort connector. Right? Well, when the USB-C protocol came out, they actually decided to incorporate other things besides USB-C in the spec, which means that the cable itself is capable of carrying signals other than USB. So with A and B cables, all you can carry is a USB signal. With a C cable, you can actually carry USB, DisplayPort, and enough power to power your laptop. So when Intel looked at this situation, they realized, well, we've already got DisplayPort in here, and we also have this laptop power and USB. Why don't we just take Thunderbolt and put it into a USB-C cable? So with Thunderbolt 3, it basically adds PCI Express to USB-C, and because of that, Thunderbolt 3 has PCI Express, USB, DisplayPort, and enough power for your laptop. And that is the reason that Apple has switched to one port on their machines, or at least on the MacBook Pro, because it's capable of doing everything. No judgment on whether it was a good idea, but it's capable of doing everything with this one cable that you used to have to do with 3 or 4 cables. Did you have a question?
Yeah, so when you say laptop power, you're talking about powering the device from the laptop through the cable.
I'm talking about that, but I'm also talking about powering the laptop itself. Yeah.
From the device that's attached to a cable to the wall?
No, from just with the USB cable. So for example, with the newer Apple laptops that have Thunderbolt 3, the power, instead of using the MagSafe connector that you're probably familiar with, the power is actually a USB cable.
Got
Make
it.
sense?
Okay, yeah.
So laptop power is enough power to power your laptop. Okay, so I've thrown a lot of information at you, but I haven't really given you a way to visualize that information. So let's take a look at the capabilities of some of these cables. So let's start with a USB A and B cable. With a USB A and B cable, we can transfer one thing. We can transfer it really fast, but it's still only, well, not that fast, but it's still only one thing. So a USB A to B cable can only transfer USB. That means it can't transfer anything else on this list, and when it transfers USB, it can transfer it at 480 megabits per second or 5 gigabits per second. I do realize that that says gigabits per second. I have to fix it. Next, we have mini DisplayPort. So a mini DisplayPort cable can transfer only one thing as well, and that's DisplayPort. Then we have a Thunderbolt 1 or 2 cable. Thunderbolt, as I mentioned before, adds PCI Express, and it can also transfer DisplayPort. So you can get video and file transfers, and you can hook up external components, because PCI Express allows you to hook up external components. And it can do that at either Thunderbolt 1 speeds or Thunderbolt 2 speeds, depending on the chip that's in the computer. It's the same cable for Thunderbolt 1 and 2, it's just the chip that's different in the machine. Then we have the USB-C cable, which I mentioned takes a USB cable and adds DisplayPort and enough power to power a laptop. And it also adds in USB 3.1 Gen 2, which gives you twice the speed of traditional USB 3. Right? So these are all great, but none of these fill all of the categories until you get to Thunderbolt 3. Thunderbolt 3 can provide USB, DisplayPort, PCI Express, and enough power for your laptop. So just reiterating, this is why Apple thought it was a good idea to switch to one port on their newest machine. Well, one type of port on their newest machines, because you can do all of these things with that one cable. So USB-C is fantastic, and it can do a lot, as you see here, but there's one caveat, which is that it can do a lot, but it doesn't have to do a lot. And what I mean by that is when Intel introduced USB-C, they told manufacturers that they could pick and choose what they do and do not support in the cables. So for example, you could buy a USB-C cable that only has USB 2, nothing else. You could buy a USB-C cable that only has, well, it's not very common, but you could buy one that only has DisplayPort. Or you could buy one that only has USB 2 and enough to power your laptop.